Hello to all. This video is going to be for chapter 7 lesson 5, which is about factoring special products. Now in the previous two videos we did see how to factor trinomials when there is the value of the a term as well as when there is no value for the a term. So this lesson is going to be about how to factorize special products. So it's a very easy part, rather than you will find it more easier than the previous two lessons. So the first part, before I start solving the questions, I would like to just give the clue for you of what the lesson is going to be about. Now this lesson, there are definitely two objectives in this lesson. One is to find the perfect square and another one is to find the difference of two squares. So this is what the lesson is about. So a trinomial is always a perfect square if the first and last terms are perfect squares. Now we all do know what are perfect squares. Perfect squares are the numbers which can be written in a square form. For example, 16. So the square root of 16 is 4. Similarly, 25. So the square root of 25 is 5. So these are called as perfect square numbers, where you will have just two numbers, same numbers. When you multiply, you will get the answer. So do you think 64 is a perfect square? Is 64 a perfect square? Yes, it is, because it's going to be 8 and 8. How about 63? Is 63 a perfect square number? No, it's not, because 7 multiply 9 gives us 63, and there is no number with which we could multiply and get a 63, which we could get the same numbers. For example, in this one, 8 eighths, 9 nines are 81, so 81 is a perfect square. Similarly, it's like a pattern, in fact, we follow. So perfect square numbers are the numbers which could be written as the product of the same number. So it's the next square number after 4 is going to be 9. So the next square number after 9 is going to be 16. The next square number after 16 is going to be 25. So this pattern continues. 2, 2, 3, 3, 4, 4. So whichever numbers you get by multiplying is called as a perfect square number. Now, why did I explain that? Because this is what you're going to be looking into in this lesson. A trinomial is a perfect square if the first and the last terms are perfect squares. So to know whether the numbers are perfect squares, definitely you need to have an idea about perfect square numbers, right? So these are the two conditions which you need to keep in mind when you're finding if a trinomial is a perfect square. The middle term is 2 times one factor from the first term and one factor from the last term. Well, just hold on, I'll explain you clearly what they mean. So if they have given you a trinomial and if they're asking you if it is a perfect square, what you need to do is you need to divide the first term in two equal parts. For example, the root of 9 is 3. Right, the root of 9 is 3, which means now this x with the exponent x square, which means we could write it as x multiplied by x, because you know x multiplied by x gives you an x square, which means 9x square can be written as 3x multiplied by 3x, right? So this could give us a 9x square. If you multiply this, you will get a 9x square, which means the terms are the same. Similarly, if the first term is a perfect square, move on to the last term, because we're going to look at the perfect squares of the first and the last term. Now, is 4 a perfect square? Yes, it is, because 2 multiplied by 2 is 4. So again, now if the first term and the last term are perfect squares, you need to still check if you would multiply the first and the last term with a 2, whether we are going to get the same terms or not. So you take each term, that's the perfect square of the square root of 9 is 3, and the x square we found out it's 3x. So we need to take each term and multiply and check whether we are getting the term which is in between. So let's check. 2 multiplied by 3 is 6. 2 multiplied 3x is going to give you a 6x. 6x multiplied by 2 is going to give you a 12x, which means this is a perfect square trinomial. This is how you find out whether the trinomial is a perfect square or not. So the steps are: first find the root of this first term, then find the root of the next term, then always multiply with 2 and check each term, multiply with 2 and check one term from the first term and one from the last one. You multiply them and check whether you are getting the middle term. If you are getting that, that means this is a perfect square. Now the next idea of this lesson is about finding whether the polynomial is a difference of two squares. So usually you will get binomials like this and they will ask you if it's a difference of two squares. Now keep in mind they are talking about difference, so it always needs to be a negative one. Now there are two terms, one subtracted from the other. So what are you going to do is, again, you're going to divide them perfectly into square numbers. So 2x multiplied by 2x would give you a 4x. How do you find out the root of 4x square? The root of 4 is 2, which means 2 multiplied by 2 is 4, and then x square. So we could divide the exponent as 1x here and 1x here. So the square root of 4x square is going to be 2x. So 2x multiplied by 2x gives us a 4x square. Similarly, the root of 9, square root of 9 is going to be 3. So 3 multiplied 3 is going to give you a 9. Now, if you could divide them equally, or if you could factor them equally, that means both of them are perfect squares. So to start with the first question, you have to determine whether each trinomial is a perfect square. If so, factor it. If not, we need to explain why we cannot factor it. So if you're finding whether the trinomial is a perfect square, what you need to do is you need to look at the first term and the last term. If they are perfect squares, then you need to, if you could divide them into perfect squares, then you need to multiply each term with 2 and check whether you're getting this answer which is in the middle, the term which is in the middle. So how can you divide x square in 2? X square divided by 2 is going to give you x and x. So we could divide x squared as x multiplied by x, and 9 we could divide as 3 multiplied by 3, which means x squared and 9 are perfect squares. Now we cannot decide if it's a perfect square unless we multiply each term with 2 and then whether if we are getting 6x or not. So take one term each from this, so that's going to be 2 multiplied by x multiplied by 3. So 2 multiplied x is going to give you 2x. 2x multiplied by 3 is going to give you a 6x, which means we are getting the term in between. So therefore, this is called as a perfect square. So you need to write it as, yes, it's a perfect square, and then you need to write the factorization. How do you write the factorization? It's going to be x plus 3 and x plus 3, but as you can see both of them mean the same, so we could write this factorization as x plus 3 whole square, because we are repeating the same thing twice, so we could write it as x plus 3 the whole square. Right, moving to question number 2. Again, you need to look at this first term and the last term, whether we could make them into square numbers, whether we have to find out whether they are perfect squares. So this root of 4, the square root of 4 is going to be 2. Similarly, the square root of x squared is going to be x. So we could divide this as 2x multiplied by 2x, because that will give you 4x squared. How about 25? The square root of 25 is going to be 5. So which means we could write this as 5 multiplied by 5. Now, before you write the factorization, you need to check whether if you would multiply each of this term with a 2, whether the answer you are going to get will result in the middle term. So 2 multiplied 2x is going to give you a 4x. 4x multiplied by 5. So 4x multiplied by 5 is going to give you 20x. 4 multiplied 5 is 20, and then x. So which means that's the term in between, which means we could factor this into a perfect square, say yes. So the factorization is going to be 2x plus 5 and 2x plus 5, which could be written as 2x plus 5 the whole square to the power of 2 whole square. 2x plus 5 the whole square. So the next question, here we have 36x square and 16. Now first decide, can you divide 36 into equal to number, the square root of 36. You need to find the square root of 36. So the square root of 36 is 6. So we have 6 and 6 because 6 are 36. And how about this x square? That's going to be x here, 1x and x, because x multiply x is going to give us an x square. How about 16? What's the square root of 16? The square root of 16 is 4. 4 multiplied by 4. Now, do not write the factorization unless you confirm whether the terms multiplied by 2 would give you a 24x. Always multiply them by 2 and check. So this is going to be 2 multiplied 16 is going to be 12x. 12x multiplied by 4 is going to give you 24 multiplied by 4. Is that going to give you a negative 24? This is giving you 96. So which means this is a wrong kind of factorization. If we would write this as 6x plus 4 and 6x plus 4, that's going to be a wrong factorization. Whether we write plus 4 and minus or plus plus, it's going to be a wrong factorization because 2 multiplied by 6x and multiplied by 4 is not giving us a 24x. So which means this kinds of questions can't be factored. Now they said, say why that cannot be factored. They did say that in the question, right? They said, if so, factor it. If not, explain why. So how are you going to say that you cannot factor this? You need to give this reason. Because 2 multiplied by 6x multiplied by 4 is not equal to 24x. You need to write it in this way. This is why we cannot factorize it. Because if we would be able to factorize, we need to get a negative 24 there, but we are not able to. So we need to give the reason. This is why we cannot factorize. Okay. So next question here, 9x squared minus 12x plus 4, which means we are going to find this root of 9. So that's going to give me a 3x and a 3x. 3x multiplied 3x is going to give you a 9x, okay? And 4 will be 2 multiplied by 2. The square root of 4 is 2 multiplied by 2. Now check if each term from this term take 1 and from this term take 1 and check whether that will give you a 12x. So 2 multiplied 3 is going to give us a 16x. So 16 multiplied by 2. Sorry, 2 3s are 6. So 6 multiplied by 2 is going to give us a 12x. But if you notice here, if it's 1 is negative and 1 is positive. From the previous lessons, you do know how your factorization will look. You need to change any one of the factors to get a negative 12. So if you would get a negative 12, your answer needs to be in this form. How it should be? 3x minus 2, 3x minus 2. Only then if you solve, you will get this as the trinomial. So remember always, if 1 is negative, that's a b term is negative and the c term is positive, your answer for factorization should be in a negative form. So we could rewrite this as 3x minus 2 whole square because it's the same thing which is being repeated. So one more thing to remember is, if the b term is negative, c term is positive, your answer will be in the form a minus b the whole square. We also took this lesson on how to solve a minus b square. So if you would remember that, definitely you will remember this as well, right? So this is a problem solving question. What do they say? A rectangular fountain in the center of a shopping mall has an area of this. The dimensions of the fountain are in the form cx plus d, where c and d are whole numbers. Find an expression for the perimeter of the fountain. Find the perimeter when x is equal to 2. So they want you to find the perimeter. So definitely what they're asking you to do is they're asking you to write it in a perfect square form because they said it is cx plus d. So cx plus d means a plus b form. So let me write this down. First, let me write the trinomial. So that's 4x squared plus 12x plus 9, which means I need to check if I could divide this in two parts. Can I divide? Yes, I could, because 2x multiplied by 2x will give me a 4x squared. Similarly, this one is going to be 3 multiplied by 3. So first check whether if you would multiply 2x and 3 with a 2, whether we will get 12. 2 2s are 14, so sorry, 2 2s are 4, 4x. 4x multiplied by 3 is going to give you a 12x, which means I could write this factorization as 2x plus 3 and 2x plus 3. Now, what did they say? They said the dimensions of the fountain are in the form 6cx plus d. So are they not in that same form? It is in the same form, where c and d are the whole numbers. So here, this and this are the whole numbers. 2 and 3 are the whole numbers. Find an expression for the perimeter of the fountain. So now how could we find the expression for the perimeter of a fountain? You know how to find the perimeter. The formula for perimeter of a rectangle, they said it's a rectangle, it's 2L plus 2W, right? So here, if you would notice, now definitely this is going to be the length and this is going to be the width, which means it's the same. So we could say, instead of writing 2L plus 2W, we could even say 4 multiplied by this factor. It's going to be the same, but if you want, you can still write it as 2 multiplied by 2x plus 3 and plus 2 multiplied by 2x plus 3. But rather than writing it like this, it's always better if you would have written it as 4, because 2 plus 2 is 4, so we could still simplify this. So this is the perimeter, but still we can simplify. So we could write this as 4 2x plus 3. Right? Or even you can leave it like this. It's perfectly fine to leave it like this as well, but then we can still simplify. We can still simplify. So now once we have found the formula for the perimeter, but find the perimeter when x is equal to 2. So what are you going to do? Simply substitute x in place of 2 in place of x and find out the answer. So that's going to be 2 2s are 4, 4 plus 3. So 4 plus 3 is going to give you a 7. So 4 multiplied by 7 is going to give you a 28 feet. So this is the perimeter of the fountain. So all what you needed to do is first factorize it. Once you factorize, you will get the length and the width. In the previous lesson also, we had a similar question like this, where you had to find the width. The length was given, the width was you had to find. So once you factorize, you will get the length and the width. So using that, you could write the formula using the perimeter formula, 2 multiplied by L plus 2 multiplied by W. And then still we can further simplify, as 2 plus 2 is 4 and 2x plus 3, we could take 1 2x plus 3 as common. Now if you would have done this by stopping here, instead of writing 4 multiplied by 2x plus 3, if I would substitute 2 in place of x here, still the answer is going to be the same. You could try that out. Your answer is going to be the same answer. So here it's going to be like that. 2 multiply 2, 2 plus 3. So of course you need to solve the parenthesis first. So 2 multiply 2 is going to give you 4 plus 3. And 2 multiply 2 plus 3 is going to give you 7. So it's going to be 2, 4 plus 3. It's going to be the same. So 4 plus 3. So that means again it's going to be 2 multiply 7 plus 2 multiply 7, which is going to give you a 14 plus 14, which is going to be 28 feet. So this is how you need to find the perimeter. Now whether you do this way or this way, you could see that the answer is going to be the same. Okay, so let's move on to the next part of the lesson, which is determine whether each binomial is the difference of perfect squares. If so, factor it. If not, explain why. Now, I did already explain how to find the difference of two squares. Always make sure that there should be a negative sign, because they are finding the difference. And simply we are going to check whether each of these is a perfect square or not. So to start with, first check for the sign. Is this a negative? Yes, it's a minus sign. So let's divide this into two parts. So this is going to be x and x. X multiply x will give you x squared. 16 is going to be 4 multiplied by 4. Now, how are you going to write the factorization for this? You have to write x. one is going to be plus and the other is going to be minus. If you would remember, this is one of the lessons you took as a plus b, a minus b, and you were getting the answer as a square plus b square. I hope you remember this. This is for chapter 6. We did a lesson like this, so it's the same thing. We are applying it on another side. That's all. Okay, now this one, 9b to the power of 4. Now 9, the square root of 9 is going to be 3 and 3. 3 multiplied 3 is 9. How about b to the power of 4? We will divide it as b square and b square. Why did I divide it as b square? Because b to the power of 4 can be written as b square b square, because if you would multiply b square and b square, you would get a b to the power of 4, because we're going to add both the exponents. So that's how you divide exponents other than 4, other than 2. If you just check them, whether you could divide them into equal parts. So this is how you need to write it. Now, how about 200? Is 200 a perfect square number? Is there any perfect square number for 200? There is no perfect square for 200, so which means you cannot factorize this question. So what are you going to write? You have to say no, because 200 is not a perfect square. So 200 is not a perfect square, therefore you cannot factorize this binomial. It's not a difference of perfect squares. Moving to question number 8. So it's 1 minus m to the power of 6. So which means 1 can be always written as 1 multiply 1. 1 ones are 1. And m to the power of 6. So here the exponent is 6, which means we could divide it into 2 as m to the power of 3 and m to the power of 3, or rather m cube. So how are you going to write the factorization for this? 1 plus m cube and 1 minus m cube. Well, the next question is 36x squared minus 4t squared. So 36. The square root of 36 is 6 and 6. And how about s squared? It's going to be s here and 1s here, because s multiply s is going to give us an s squared. How about 4t squared? The square root of 4 is going to be 2 and 2. Then again, t squared can be divided as t and t. So we are going to write it in the form 6s plus 2t, 6s minus 2t. It's easy, but then you need proper observations. Okay, how about this question? X squared, y squared plus 196. Do you think this is a perfect square? There's a difference of perfect square. First of all, this is a positive, there's a plus sign. It's not a minus one. That's why I have been repeatedly telling, check for the sign here, because they are asking about difference of perfect squares. So first of all, this is a plus, which means we cannot factorize this as a difference of perfect square. So just say no. The operation in the sense, the sign here, the operation between the two squares is addition. Or you could explain completely in your own words. You could rewrite this sentence in your own words and say, no, the question should be a difference, so it cannot be shown as a difference of two squares. It's totally up to you how you reframe this possibility or the explanation why we cannot factorize it in your own words. So that was this lesson. It was an easy lesson, but then you need to pay extra attention, because when you're finding if it's a perfect square for a trinomial, you need to check by multiplying with 2 whether does give you the middle term or not. And when you're finding the difference of two squares, you need to first concentrate on the sign in between it. It is a negative one, and then as well you need to concentrate if you could find the square roots of these numbers. So that was all for this lesson. Hopefully you've got the answers right. So till the next video, keep practicing.